Welcome to One Chemistry. In this video, we are going to see what is Wade's rule. It is for borane. It will help you to learn the structure of compound from simple formula. It will be very interesting. Stay tuned. Here I given very common borane compounds. It is for your quick reference. It will help you to solve the problem. It will also help you to correct yourself. Before getting to that, you have to know what are all the borane types. This Wade's rule help you to find all type of boranes: simple borane, heteroboranes, Zintl salts, borane with charges, borane as a salts. Mainly we are going to see boranes and simple charged and salt compounds. Why this rule is important? Because normally to find the structure, you have to carry out the experiment, use the machine. Here, by simple formula, you get the structure of the compound. The formula mostly work for the boranes or any kind of similar polyhedrons. So, why it is important mean you find the structure without instruments or any complex machines. So what is the theory behind that? Usually skeletal electron pair theory will be used. It was established by scientists called Wade. That's why it is Wade's rule. Why this is important mean mostly the compounds form two center two electron bond, but here it will form three center two electron bond. It's a special kind and different from normal chemistry. So this rule getting important. Now we should know the structure of the borane. For that you should know the name. The names are Closo Nido. The names are Closo Nido Arachno, Hypho, Clado, Supercloso, Hypercloso. Normally the formula is n plus m. If it is Closo, it is n plus 2 system where n is number of boron, m is number of excess hydrogens. 2 excess hydrogen mean Closo, 4 mean Nido, so on and so forth. You should memorize these names, memorize this formula. Before getting into the detail, you should know what is Closo, Nido and Arachno. Normally in polyhedral system, all vertices are intact means it is Closo. If one is not there mean it is Nido. If two is not there mean Arachno. Basically we are identifying the missing vertices. From that you can identify the structure. Here is shown in octahedron. It can be on any polyhedron. Then we will know how to find the structure step by step. First, you should write boron equivalent with hydrogen. If it is a neutral compound, it will not be an issue. If it is charged, you should write boron equivalent. First count the boron, then count the hydrogen. If charge is there, write C, then find excess of hydrogen, which is M equals H minus C minus N. Then predict n plus m. N is number of borane, m is excess hydrogen. From that you can identify Closo, Nido or Arachno. Here I given the example P6H6 2 minus. Here n is 6, it is obvious. Hydrogens are 6 and charge is minus 2. If you look at the m, it is 6 minus of minus 2 minus 6. So m equal to here n plus m mean it is n plus 2 system. So it is Closo. Then there will be a mistake indicator. It will be simple. M cannot be a odd number. If it is odd, it is a mistake. Here I give an example with simple error. Suppose you don't account the charges mean you will commit a mistake. So instead of B6H9 minus, you return B6H9 mean you get H minus C minus N, which gives M equals 1. M cannot be a odd number, so it is a mistake. So it is a simple error indicator. You should know. We can learn more by the example. So I given 5 example to understand the concept. The first example is predict the structure of B5H11. Here B5H11 borons are 5, so N equals 5. Hydrogens are 11, so H is 11. No charge, so 0. So excess of hydrogen will be H minus C minus N, which gives M equals 6. M equals 6 mean it is N plus 6 system. From table you can clearly see it is Arachno structure. So the structure of B5H11 is Arachno. Then the next example, predict the structure of B5H5 2 minus. B5H5 2 minus mean charged system. Number of borons are 5, so N equals 5. Hydrogens are 5, so H equals 5. Charge is minus 2, so C is minus 2. So excess of hydrogen will be H minus C minus N, which is 5 minus of minus 2 minus 5, which gives M equals 2. So N plus M system, M is 2 mean it is N plus 2 system, which is Closo. So the structure of B5H5 2 minus is Closo. Then the next example, predict the structure of Na2 B10H10. Don't get confused. Write the system with charges. Na2 is counter ion, 2 Na plus actually. So B10H10 will be 2 minus. So it is a charged system with counter ion. So we will go by the basics. Number of borons are 10. So N equals 10. Number of hydrogens are 10. So H is 10. Charge is minus 2. So C is minus 2. Excess of hydrogen will be H minus C minus N, which is 10 minus of minus 2 minus 10. So M will be 2. So N plus M mean N plus 2 system. It is Closo. So the structure of Na2B10H10 is Closo. Then the next example, find the structure of B10H14. B10H14 is simple system. Number of borons are 10, so N equals 10. Hydrogens are 14, so H equals 14. Charge is 0, so C is 0. Excess of hydrogen M will be H minus C minus N, which is 14 minus 0 minus 10, which gives 4. So it is N plus 4 system. So the structure of B10H14 is Nido. Then the next example, predict the structure of B2H7 minus. B2H7 minus mean charged system. Number of borons are 2, so N equals 2. Number of hydrogens are 7, so H equals 7. Charge is minus 1, so C is minus 1. Excess of hydrogen will be H minus C minus N, which is 7 minus of minus 1 minus 2, which gives M equals 6. It is N plus 6 system. N plus 6 mean Arachno. So the structure of P2H7 minus is Arachno.